Can anybody tell me the definition of work? What is the definition? In simple words, I do not need any perfect definition. Just tell me what is work.
Activity involving mental, physical effort.
This is
Activity involving physical or mental effort.
To move something against the acceleration. Apply force to move something against the gravity. Or
do not tell me. I told you that don't confuse yourself in mathematical words. Just consider me, I am illiterate and I do not know what is the definition of a work. Just tell me in simple words what is the meaning of work. In very simple words. Just
to
consider
do something.
I am illiterate.
To do something. Work is
To do something. To do something means it is a desire. You want to do something. This is a duster.
Activity involving mental or physical effort.
Look, this is a duster and it slipped out of my hand. Now this is on the floor. I'm going to pick up this duster from the floor here and I'm going to fix it here. So the effort I have made to pick up this duster from the floor and put it here is called work.
right. Okay.
Very simple. So if somebody asks you, just tell him that yes, the effort you made to do something is your work. If you do not do your effort to settle down your microphone to call the attendance, it means you are not doing any work.
Yeah.
So this was the basic simple definition, but from the virtue of the second law of motion given by Newton's, he said work is something related with a mass and acceleration. And mass and acceleration, when they are multiplied together, mass into acceleration, this is called a force. And this equation was given by Newton. If I further write this equation, I know that what is acceleration? Acceleration is the first derivative of velocity. And if I further write this equation, I know that velocity is the first derivative of distance. So it becomes m d square s by dt square. Now forget about all these terms and focus on this and this. In this equation, m is the mass of whatever thing you are going to pick up, and s is the displacement which you have covered. For example, when I was picking up the duster from the floor to this height, there was a distance. That height is actually the distance which the mass has traveled by virtue of my effort on it. So that distance is s, and the second derivative of that distance together with the mass multiplied together is called the force. And if this is the force, then what will be the definition of work? When I pick up this duster from the ground, what I need?
Force.
I need some power to pick it up, and that thing is called the force. the power, which is together a combination of the mass of this thing and my ability to pick it up, the acceleration. For example, when we talk about the picking up it from the ground, then it means there is a gravitational pull which is actually pulling this guy downwards towards the earth, and I am putting some force to pick it up, and that force is actually the mass which decides how much I will pick it up. Together it becomes the total force, and the definition of work is that force into the distance which you travel. So the force required to pick up and the total distance which you travel, when you multiply them together, it becomes work. You know this from physics 1, and maybe you are the student of physics 2. Right now, maybe you are the student of physics 2, right?
No.
Which part of physics are you studying now?
Nothing, we're not studying physics. Yeah.
I saw physics in the timetable.
No.
Anyways, so the work is calculated by multiplying the force into displacement. For example, the question is, how much work is done in lifting? Part A. How much work you have to find the work in lifting a 1.2 kg book off the floor to put it on the desk. My book is on the floor and the weight of the book is 1.2 kg, mass of the book. And I pick this the book from the floor and put it on my desk. The question is, what is the total work done in this whole activity? When? Now what I need? If this is the ground and here it is the desk. So book is actually here and I'm going to pick this book from here to put it here. Then what I need this distance, which is the height of the desk. Of course, the desk is also placed on the ground and the book is also on the ground. So they are at the same initial position, but the desk has this height. So this height is actually, this will be the distance which the book will travel from this point to this point. So I need this data so that I can put them into there. So the question, in the question they have given to you the data. The first thing is the mass 1.2 kg. Second thing is this height, and it is also given to you. The height is 0.7 meter. And now third thing, sometimes it will be given, sometimes not. To find the force, you need mass into acceleration. So if you are moving horizontally, then the acceleration is a different thing. But when you are talking about the activity picking up vertically, then of course the acceleration will be the force of gravity. And the force of gravity is a general unit already given. So sometimes if it is their choice, they will give you this value, 9.8 meter per second square. Sometimes they will not give you, so you know this value. This is a universal truth that the gravity on earth has this value. This is the acceleration by which the center of the earth is pulling the things towards it. Anyways, so I have this data. Now I can calculate the force. The force is mass into acceleration, and in this situation, when you are picking up the things vertically upward, the acceleration becomes mg. You know the m, it is 1.2 and the g is 9.8, and the units are, one is meter, this guy is meter, and this guy is kilogram. So it will become 11.76 kilogram meters. And in other words, since the force was defined by Newton, so the unit of force is also called newtons. This is also true, but you can also write it as 11.76 newtons. And both are the units of force. But this is more beautiful because this relates the origin of this whole equation. Now you have the force and you have the distance. The height is actually the distance which the book will travel. So you know the formula for work. The work formula is F dot D, F into D. You know both of these values. Now you calculated the force and you know the distance. Put them here and that will be the amount of work. Force is 11.76. The unit is newtons into the distance is 0.7 meters. And when you multiply them together, it becomes 8.2 Newton meters. And the other name of Newton meters is joule, which is actually the
Joule.
standard unit of
Work.
work. So your work is always considered in joules, Joule
Yes.
maybe.
Yes.
This is the unit of work.
Yeah.
So both are fine. If you write Newton meter, still it is fine. But more beautiful is 8.2 joules because mostly we talk
Right.
work in terms of joule. Second question is, instead of this data, if the given data is like this, if they give you that force is 20, lb is another unit, which is when we talk about meters, then we talk about kilogram meters in terms of newton. When we talk about feet, then we use this unit lb. So this is linked with feet, meter is linked with kilograms, things like this. So force is given like this, and the second thing given to you, the height. If the height is 6 feet, the question is what will be the work. In this case, the thing is very simple. You know that work, this is height is distance, so the work is FD. Simply put these values, multiply them together, so it is 120 lb feet. And lb feet is also equal to joules, but it is coming from in terms of feet, and this guy was coming from in terms of meters. Both are equal. The unit of work will always be joules. What is the difference in two parts, A and B? The difference is, in the first part, you were not directly given the force, but you were given the components of force, the mass and the acceleration. So, if you have mass and acceleration, then first you can calculate the force and then you can put the force together with the distance to find the work. In the second part, they give you the force directly. So you don't need to do this step. You have the value of F, simply multiply it with the distance, and that's your answer. So the second one was the simple version as compared to the first one. Now, one last improvement to this whole thing is that this work is calculated when the force is constant, when the acceleration is constant. For example, you are picking up this duster and you are moving it from the bottom to up, then of course the mass is constant, because this duster, the mass will remain the same within the limitations of the gravity. But it is always up to you to change the acceleration. So from the start, maybe you pull it slightly, then you move fast, very fast, very fast. So at every single step, you are changing the acceleration. And if you are changing the acceleration, it means your force is no more constant. You are actually changing the force, because force is a component of mass into acceleration. Mass is constant, but this guy is changing. This is variable. So if this is variable, a constant into a variable, say x is the variable, then the whole equation means the force becomes variable. So you are actually changing your force at every step of the time interval. of the distance interval, sorry. For example, okay, let us draw the vertical. If your distance is like this, then and the total distance is say 1 meter, but your acceleration, your force is changing continuously. Now it is up to you that how much slices you make for this distance. We are again going back to the integration.
Right. This is again the delta x,
Yeah.
which is will be the
Now it depends that
d or
how,
h, right?
yes, now it depends how small you divide this total distance. The smaller you will
Right.
divide, the more accurate will be your answer for the work. So if you
Because
split
we don't
these
know the
things,
rate of change of, or we don't know the intervals where
wait.
acceleration is changing.
If you keep changing these things and you
Right.
split, this is your A, this is your B. Now, if you are confusing into this, just take this and put it like here, which we already know. So this is your A and this is your B, and this is the total height. This is the ground and this is the desk. It was like vertical, but we are familiar with this, so I put it on the like this. So now when you split this whole thing into the small slices, and your this AB means this is the initial position H naught, and this is the final position HF, the height. So in between, this is the total height H. So you are actually dividing the displacement into smaller parts of the displacement. And when you divide the displacement into smaller parts and you keep this guy, of course, the smaller parts of the H will be delta x. Now it depends how much size of the delta x you are doing. So the delta x you will keep constant. Of course, you will fix a delta x that will be b minus a divided by the number of intervals. That will be a fixed quantity. Then what is changing? The changing guy is force. If changing guy is force, then you can represent f as f of x. So instead of capital F of x, I am saying suppose the force is a function f of x, small f of x. Then what are you doing? You have cut down the whole region into slices and you are going to calculate for all the small intervals the work one by one. The work 1 for the first interval, work 2 for the second, work 3, and so on. For any ith interval, you are going to calculate the work I, which is for the interval I minus 1 to I. Same concept coming here. So for this specific interval, your work will be Wi, and this Wi is simply the multiplication of what? The force at the midpoint of these two. Suppose this is xi steric. This is the force in between these 2 points which you are applying to pick up the duster from the ground to the level. So you have split up the whole height into small pieces. So now this is one small piece in which you are saying that yes, for this small piece, I am assuming that for this smaller piece, the force was constant. Similarly, for every piece, the force was constant, but every 2 pieces have different force, continuously changing. So for that specific ith interval, I can calculate the work I, and I know the general formula of work is F dot D. It means if I am calculating the variable work, Wi will be the force on the ith part into the displacement delta x. This is okay?
Yes.
Let me here. I am picking up the duster, keeping moving. I have split this whole guy into small steps, and I am saying that from here to here there is a quantity of force, let's suppose 2 newtons. And then from here to here the quantity of the force is suppose 3 newtons. So it is changing. From here to here, suppose it is 1.5. For example, here it is 2, here it is 3, it is 1.5, later it is 0.1, later it is 3.1. So every moment it is changing up, down. Somewhere I am tired, somewhere you can relate this with daily life. If you start moving when you have done the breakfast, then initially you will walk very fast, and after some time you will become dehydrated and you will slow down your speed. So you're actually picking up some burden on yourself, and your continuity, your acceleration is changing at every moment. So it is not that always it is increasing. No, initially maybe it is 2, later maybe 3, and then suddenly it drops down. You stop somewhere and then increase, then dropped. So every step is changing. Now I am here, I reach here, and I say, suppose this is the ith moment of my journey from the floor to the top of the desk. And this ith moment, of course, it has some initial point which is called I minus 1 and some final point which is called I. This is the interval I minus 1 to I. And this interval belongs to x, the displacement. So it is xi minus 1, xi. In between these two guys, I know that I can take up a midpoint. That will be xi steric, and xi steric is always equal to previous one plus the final one divided by 2. So I have picked up this xi, any midpoint of this interval of my journey, and this guy is put into the function of the force. This f is now force function. In the case of volume, this f was area function. Here it is a force function. When I put this value into here, and this is the step size, the distance which I will travel from this point to this point, delta x. So this multiplication will give me the total work done only during this part. Now if I want to know the total work from here to here, the same. The total W will be the sum of all the works from I equals to 1 to I equals to n f of xi steric delta x. And I know that this becomes more better if I replace it with limit n approaches infinity, sum of I from 1 to n f of xi steric delta x. And I further know that this can be written as the W is equal to integral from a to b, from a to b, f of x dx. But in this case, the function is force function. Understand?
Yes.
Yes, sir.
Let's do an example and then we can stop. Example is a particle located at x feet from origin. X feet is the distance from origin. And a force f of x equals to x square plus 2x pounds. X on that particle, which is x distance from the origin. If this is the origin, then somewhere here the particle is sitting. How much work is done in moving from x equals to 1 to x equals to 3? So you are given the work function, force function, you are given the A, which is 1, you are given the B, which is 3. So you know that the work done is integral from A to B, the force function into the step size. That is integral from 1 to 3, the force function x square plus 2x into dx. And you know how to solve this it will be x cubed by 3 plus 2x squared by 2 under the limits 1 to 3, and when you put these values together, the answer is 50 by 3 lb feet. That's the answer. That's it. So the only thing is, when you have variable acceleration, it means your force will become variable, and in that case your force will always be a function of some x. It will never be a fixed real number. In the first part, when we said that the force is constant, and assuming that acceleration, because we said that gravitational acceleration is 9.8 and it is always constant. So if acceleration is constant, then the force is a constant number, any real number. Whatever the mass and gravity multiplied together will give you a constant real number. So in that case, force was constant and the total distance was constant. So when they multiply together, your work is force into distance. That's it. But this was the case when acceleration was constant. So real culprit is acceleration. If the acceleration changes, it means ultimately your force will change. And if the acceleration is changing at every single movement of your feet, then it means the force is changing at every single movement of your feet. And if force is changing, then it will never be a real number. It will be some kind of a function. X squared plus 1, any function, but in terms of x, because every changing movement, the value of x will change, and this value of x will determine the quantity of the force. So in case of variable force, you will always be given a function of force in terms of x. So this function you can put into this formula, but only thing is the understanding of what is this function. This is the force function, and this will be given to you. If it is not given to you, maybe they can give you the acceleration function. For example, I can give you that mass is 10 and the acceleration a of x is something like x squared plus 1. Then you can calculate the force function. The f of x will be the mass into acceleration. It will be 10 into x squared plus 1. So this is the force function, the smaller f of x. So you can put this force function into this formula. So it is not always that they directly give you the force function. They can give you the components of the force function, but always the acceleration will be variable. Either they directly give you the force function in variable form, or they will give you the components. You can see the mass is not changing unless you cut down something on the way. Otherwise, the mass is constant. When you pick up the book from the floor, it is 1.2 kg. You put it on the desk, it is still 1.2 kg. So mass is constant. This guy is changing. If this guy is also constant, this formula is valid. If this guy is variable, this formula is valid. That is the difference between these two formulas. So both of these two formulas represent the work done. But this is for the constant acceleration. This is for the variable acceleration. Understand?
Yes.
Okay, we are done for today. See you next week.
Oh, nice. You finish early.
Yeah,
Nice.
it's too much.
Alright. But it was good today.
Yeah, it depends.
Yeah.
But of course, the purpose of our all this activity is just to get a clear picture what is happening. There is
Right.
the, like, I can do the other thing. I can just put the PPT inside and ask you to read it, but you will not never understand,
Right.
because whether you understand, whether you read the book or PPT, you will never go into the deep inside. So the only purpose
Right.
of this whole thing is just we should understand what is happening. If you understand, then this whole thing is very easy. You know that the formulas,
Right.
but you can see we are linking
Yes.
the very basic and the concept of integral to every next movement. we are linking that thing. If you do not know,
Right.
if you do not know the first area under the curve stuff, you will be puzzled throughout the way. So if
Yes.
still you are struggling, then go back and understand that concept. Go back, understand the area under the curve. If you understand that, you can understand the whole advanced mathematics too. And if you don't understand that one, you can never go further. Okay,
All right.
see you next week. Take care.